Hey, we're solving some more practice problems using the quadratic formula. So these are quadratic equations. This one is 5x squared plus 3x plus 1 equals 0. So unlike some of the previous problems, this one is already in the correct format, and we can go ahead and identify the a to be 5, the b to be 3, and the c is 1. So in that, we're going to set up our formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a, and I'll keep highlighting these. So a was 5. Let's see here. B was 3. And C was 1. So let's clean up a little bit. We'll have negative 3 plus or minus the square root of 9 minus 20 all over 10. And this gives us negative 3 plus or minus the square root of negative 11 over 10. So the main problem here is that we've got down to the square root of negative 11. 11 doesn't break down at all, but we can't leave that negative in there. So we will pull it out as an I, and we will have negative 3 plus or minus the square root of 11 I on the outside all over 10. There is no reduction left for that problem. Okay, but you got to be aware and pay attention to your signs under that root, because you can get these imaginary numbers. Okay. Last practice problem here. B, 8x squared plus 6x equals negative 5. Things are not in the right place because it needs to be set equal to 0, so I'll add 5 to both sides. There's not a constant on the 5 right on the left hand side right now, so be careful. But that gives us 8x squared plus 6x plus 5 equals 0, and that's what we're going to work with, where our a is 8, b is 6, and c is 5. So let's see if we can plug these in. So I'm going to plug into my formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And I'll go back and highlight some things. The a I plugged in was 8. So I can do this to help myself make sure I didn't make a mistake. The b was 6. And the c was 5. So everything is in place. So let's see if there's any cleanup here. Negative 6 plus or minus the square root of 36 minus 4 times 8 times 5. 4 times 8 times 5. I'm mashing buttons. I get 160. All under the root, and that is over 16. So let's clean up that root. It's negative 6 plus or minus the square root. I know that's going to be negative, but let's see. 36 minus 160 is negative 124. All over 16. Alright, so I'm going to pull that negative out from under the root, and that will be negative 6 plus or minus the square root of 124i all over 16. Now let's see if this 124 does anything. 124 is divisible by 4, I can tell. 4 into 124. 31. Okay, I don't think 31 does anything, but I did get a pair of 2's here. So I can continue this and say that x is -6 plus or minus, and the square root of 124 breaks down to be 2 square roots of 31. Don't forget the I on the outside. There's a 16 in the bottom. As I said, that 16 can't reduce with just one of these pieces at any time, but it can reduce with both of them. So I don't know if I've got another color, so I don't do anything crazy here. But let's see here. Let's go back. The 6, the 2, and the 16 all have a common factor of 2. So I can reduce that down to -3 plus or minus the square root of 31i all over 8. And there's nothing more I can do with that. And it is, once again, an imaginary complex number. I could separate into complex parts if I wanted to, but I'm just going to leave it there. All right, thank you.